Welcome to DK Math Academy. In this class, we will discuss about limit. In the previous classes, we have discussed about set theory and function. In the present chapter, in the present class, we discuss about the limit of a function. The limit of a function. Here, at first we know this symbol. This symbol is called tends to. Tends to. That means goes to. Goes to a number something. Suppose x is a variable. X is a variable and a is some particular number, real number. Then this symbol x tends to a. That means x tends to a means x tends to a. That is x goes to the number a. Now x can go to a in very close region from the left side of a and the right side of a also. Suppose we clear this concept by an example. We consider these numbers. We consider these numbers. Dot dot dot. 1.9, 1.99, 1.999, 1.9999, etc. They are less than 2 and very close to 2. Very close to 2. They are approximately equals to 2. That means these numbers goes to 2 from the left side of 2. From the left side of 2. This is symbolized by x tends to 2 minus. This minus is just for a symbol. This means x tends to 2 minus means x goes to 2 in very close region from the left side of 2. But if we consider these numbers, 2.01, 2.001, 2.0001, dot dot dot, these numbers are greater than 2. These numbers are greater than 2, but we can understand that these numbers are very near to 2, very close to 2, but they are in the right side of 2. Right side of 2 means the numbers which are greater than 2. So these numbers goes to 2 from the right side of 2. This is symbolized as x tends to 2 plus. So x tends to a minus means x goes to 2, x goes to a from the left side of a, and x tends to a plus means x goes to a from the right side of a. Here this can be combined as x tends to 2. X tends to 2. So x going to a, x tends to a means x going to a from the left side or right side, but they can never be equal to a. Here x can never be equal to a. X is not equal to a. So x tends to a means at first we learn about know these symbols. Tends to means goes to. Then x is a variable, a is a number, x goes to a means x is very near to a. They are coming from left side or the right side. Now, what is the meaning of x tends to infinity? Infinity means however large. X tends to infinity. This means that you can think about a number however large. Suppose g. However large a number we think about, we see that x is greater than g. X is greater than g. X is large, more large from g. That means if we think so many large number, how much large number g, x will be greater than that. Similarly, x tends to infinity, minus infinity. X tends to minus infinity means minus g is large than x. Minus g is large than x, where g is, however, large number. Now we discuss about the existence of a limit. Now we discuss about the existence of limit. Existence of limit. As we see that x tends to a means x can goes to a from the left side, or x can go to a from the right side. Here, to say a limit of fx as x tends to a, this is called limit of fx as x tends to a. This limit can be breaked as limit of fx as x tends to a minus, and limit of fx as x tends to a plus. We say that this limit exists if these two limits are equal. These two limits are equal. This limit will exist if these two limits are equal. Otherwise, we say that this limit does not exist. Suppose we know that mod x equals to x for x greater or equals to 0, minus x for x less than 0. Now, limit x tends to 0 minus mod x by x, that means limit x tends to 0 minus, that means x goes to 0 from the left side. Left side means they are less than 0, that means negative. So here mod x means minus x. So limit x tends to 0, this becomes minus 1, this equals to minus 1. Limit of a constant. What will be the limit of a constant? Constant means fixed. They stand at the same position always. So that's limit, that is the limit of minus 1 will be minus 1. There is no change. Limit x tends to 0 plus. That means x coming to 0 from the right side of 0. That means these x are positive. So limit x tends to 0 plus. Mod x means x. So limit x tends to 0 plus. This is becomes 1, so 1. Here, these two are not equal. These two are not equal, so limit x tends to 0. Mod x by x. This limit does not exist. This limit does not exist because left-sided limit and right-sided limit of the function mod x by x are not equal. Left-sided limit is minus 1 and the right-sided limiting value is 1. So this limit does not exist. Now we see another one example. Limit x tends to 2, x square minus 4 by x minus 2. Here, limit x tends to 2, x minus 4 can be written as this. Here x tends to 2 means x not equals to 2. That means x minus 2 is not equals to 0. X tends to 2, that means x minus 2 tends to 0, that means x minus 2 not equals to 0. So x minus 2 can be divided from both. So limit x tends to 2, this becomes x plus 2. Now we put the value of we put the value 2 at the place of x, but in this case we have to remove this symbol, this limit symbol, because we have said that x tends to a means x is not equals to a. X tends to 2 means x not equals to 2. But here we put x equals to 2. So this written form will be removed. So this becomes 4. So the limiting value becomes 4. Now we see some theorems and some fruitful formulae to solve the problems on limit of a function. Some theorems. Suppose fx and gx, suppose fx and gx are two functions and limit extends to a, fx and limit extends to a, gx are exist, and c is a constant. C is a real number, is a fixed real number, that means constant. Now our first theorem is that limit of a constant as x tends to a is that constant. Limit of cfx as x tends to a is equals to c into limit fx as x tends to a. Limit of x tends to a, fx plus gx, this is equals to limit x tends to a, fx plus limit x tends to a, gx. If we put there, if we use minus here, then it will be minus. Limit x tends to a, fx into gx, this is equals to limit x tends to a, fx into limit x tends to a, gx. Limit x tends to a, fx by gx equals to limit fx as x tends to a by limit gx as x tends to a. Now we see about the following formulae. Here obviously limit gx as x tends to a not equals to 0 and gx not equals to 0. Now a to the power fx, its limit as x tends to suppose a, this suppose c, then it will be c to the power limit fx as x tends to a. Now if we take the limit of a composite function f naught g of x, then it will be f limit gx as x tends to a. Limit x tends to a. Now we see some useful formulae to solve the problems of this lesson, of this chapter. Some formulae. To overcome boringness, this type of design is required sometimes. Limit x tends to a, first formula, limit x tends to a, x to the power n minus a to the power n by x minus a. This will be n a to the power n minus 1. N a to the power n minus 1. Limit x tends to 0, a to the power x minus 1 by x. This will be log a to the base e. Here a will be positive. Then if we put here e, a equals to e, then this becomes log e. That means log e to the base e. That means this is 1. Limit x tends to 0, e to the power x by x equals to log e to the base e. That means 1. Limit x tends to 0, sin x by x, this is 1. Limit x tends to 0, log 1 plus x by x, this is also 1. Now, limit x tends to 0, 1 plus x whole to the power 1 by x. This will be e. Limit x tends to infinity, 1 plus 1 by x whole to the power x. This will be also e. Now we use two formula. X tends to 0, x sin 1 by x, this is 1. Sorry, this is 0. Limit x tends to 0, x cos 1 by a, this is also 0. These are the limits. Now we follow some important examples, important questions we have marked. I have marked here. At first, we solve these problems. Limit x tends to 0, root over 1 plus x minus 1 by x. Here, the function contains a third term. We will take the complementary side of this. Root over 1 plus x minus 1. Its complementary side will be root over 1 plus x plus 1. So that here will come x, and this x and x will remove. Limit x tends to 0, root over 1 plus x minus 1 into root over 1 plus x plus 1. Its complementary side. Now, limit x tends to 0. This becomes under the formula a square minus b square. A square minus b square equals to a plus b into a minus b. Here a plus b into a minus b. If we think that a equals to root over 1 plus x and b equals to 1, then this will be a square minus b square, and this is root over 1 plus x as usual. Limit x tends to 0, this becomes 1 plus x minus 1, and this becomes 1 plus x plus 1. Now limit x tends to 0. Here this x will remove. Limit x tends to 0, root over 1 plus x plus 1. This equals to, we put x equals to 0, but if we put x equals to 0, we have to remove this written form limit x tends to 0, because x tends to 0 means x goes to 0 very near to 0, but x cannot be equal to 0. But if we put here x equals to 0, then we have to remove this limit x tends to 0. So this is root over 1 plus 0 plus 1, that means 1 by 2. So the limiting value of this function root over 1 plus x minus 1 whole divided by x is equals to half. We see the next problem. Limit extends to infinity. Suppose limit extends to infinity, 3x square minus 5x plus 2, 6x square plus 2x plus 3. Suppose if x tends to infinity, then 1 by x should goes to 0. If x tends to infinity, then 1 by x, as x will increase gradually, then 1 by x will decrease gradually, and x goes to however large direction, then 1 by x comes towards 0. So we solve it as this. We divide by x square. Here x square is the highest power of x, so we divide the denominator and numerator by x square. Then this becomes 3 minus 5 by x plus 2 by x square, and this becomes 6 plus 2 by x plus 3 by x square. Afterwards, x tends to infinity means 1 by x and 1 by x square tends to 0, and so 5 by x, 2 by x square, 2 by x, 3 by x square, all are goes to 0. So this limiting value becomes 3 minus 5 into 0 plus 2 into 0 divided by 6 plus 2 into 0 plus 3 into 0. So 3 by 6, this is also half. This is also half. Now we see the next problem. Limit x tends to 0, sin inverse x by x. Here sin inverse x is present, means we put x equals to sin theta. Now x tends to 0 means sin x should tends to 0. That means theta is also tends to 0. Sorry, sin inverse x. X tends to 0 means sin inverse x tends to 0. That means theta tends to 0. So limit x tends to 0, sin inverse x by x, this transformed to the limit in terms of theta, as theta tends to 0 of the function sin inverse sin theta by sin theta. That means this becomes theta tends to 0, theta by sin theta. Then we can write limit theta tends to 0, 1 by sin theta by theta, and this equals to limit theta tends to 0 of 1 and limit theta tends to 0 sin theta by theta. So limit theta tends to 0 sin theta by theta, this is 1, and limit of a constant is that constant, so 1 by 1. So here this limiting value becomes 1. So the limiting value of the function sin inverse x by x, as x tends to 0, it becomes 1. We see the next question. Limit x tends to pi by 2 cos x by 1 minus sin x. Limit x tends to pi by 2 cos x by 1 minus sin x. We know a formula of trigonometry. We use here two formula. Cos square x minus sin square x equals to cos 2x. This formula. Here So cos x will be cos square x by 2 minus sin square x by 2. Cos square x by 2 minus sin square x by 2. And this will be cos square x by 2 plus sin square x by 2, because we know that cos square something plus sin cos square theta plus sin square theta equals to 1. So we write here cos square x by 2 plus sin square x by 2 minus, at the place of sin x we can write 2 sin x by 2 cos x by 2. 2 sin x by 2 cos x by 2. So limit x tends to pi by 2. This is a square minus b square. That means a plus b into a minus b divided by, this is a minus b whole square. A means cos x by 2 and b means sin x by 2. X tends to pi by 2. This becomes cos x by 2 plus sin x by 2, and this is cos x by 2 minus sin x by 2. Now we divide by cos x by 2. Then this becomes limit x tends to pi by 2, 1 plus tan x by 2 by 1 minus tan x by 2. Here at the place of 1 we can write tan pi by 4. Tan pi by 4, and this is as usual tan x by 2, and this is 1 minus tan pi by 4 tan x by 2. So limit x tends to pi by 2, tan, this is the formula of tan a plus b. That means tan a plus tan b by 1 minus tan a tan b. A means pi by 4, b means x by 2. So this is pi by 4 plus x by 2. Now x tends to pi by 2. So we put here x equals to pi by 2, and this becomes, this will be removed. So this is tan pi by 4 plus pi by 2, sorry, half into, at the place of x, this is pi by 2. So this becomes pi by 4 plus pi by 4, tan pi by 2. This is infinity. So the value of this limit becomes infinity. Here we have used some formula of trigonometry. Cos square x by 2 minus sin square x by 2 means cos x. 2 sin x by 2 cos x by 2 means sin x. And here a minus b whole square formula. Here tan a plus b, that means tan a plus tan b by 1 minus tan a tan b. So this becomes infinity. Tan pi by 2 means infinity. Okay, we have completed the chapter limit. In the next class, we will solve some important problems, and I give you some homeworks to solve the problems on limit of a function. Thank you.